Today we are going to see an application of definite integral. In fact, it's the area under the curve. We already seen this example on the class, but you need more examples to be more clear about how to do the process. And this is very important and necessary to clear out the doubt that you have for make the next evidence, the evidence number 1 of the unit number 2. In this case, we have the example that said, according with the math function f for x equal to cube x plus square x minus 3x, calculate the area under the curve in the interval -2 to 2. As you can see in the graph, the -2 start over here and 2 finish over here. According with the definition of the area under curve, the corresponding area that we can calculate through the integral, it's going to be the next one. Then I'm going to fill with lines. In this case, it's going to be this one, the first one, second one, and third one. Remember, the area under the curve is the area that you have from the axis. In that case, is x-axis because it's f for x, and the curve. This area is going to be positive, this one is going to be negative, and this one is going to be positive also. You cannot calculate the total area from -2 to 2. You need to make a sections. First of all, you need to start from -2 to this point, that in that case is obviously that is 0. And the next one is going to be from 0 to this point, that in that case is not a point that is very clear the value of that. And the third one is going to be from this point to 2. So it means that we're going to make 3 integrals. But let's talk about the points that we don't know about that. For example, in this case, as you can see, this function cross the x-axis, and remember, this is very important, x-axis, and is f for x. All the times that the function cross the axis of the independent variable are called roots. In this case, we have this one, then I'm going to call A, this one, then I'm going to call B, and this one that I'm going to call C. Those 3 points are called roots of the function. And the thing is, how to calculate the roots of the function? It's very simple. You need to make the equal function to 0, and then you need to look for numbers that substitute over here, here, and here. It's going to give you 0. So in that case, we're going to rewrite the function x cubic plus square x minus 3x equal to 0. So this is the first step to know the roots of the function. But how to know what is the value that substituted here, here, and here is going to give you 0? Well, it depends on the function how to calculate it. In that case, first of all, you need to make a breaking factors to make a factorization. In that case, we have a common term. As you can see, I'm going to take the common term that is x, and then I'm going to have x squared plus x minus 3 equal to 0. The first root that I'm going to get is, if I take all this trinomial and put it over here, I'm gonna pass like a division, and 0 over this one is going to be 0. So the first root is going to be x equal to 0. As you can see, this is the first root that is correspondent with the letter B. In other hand, if I decide instead to move this trinomial divided over 0, I decide to move this x over 0, obviously this is going to be 0 again, so I'm just going to have x squared plus x minus 3 equal to 0. So as you can see, we have a function of second degree. In that case, you have two options. Sometimes you can make a factorization, and this factorization is going to give you the roots. But if you cannot do that, the other option is to use the general formula. In that case, as you can see, we can try for factorization. You only need to look for a number that multiplying by itself is going to give you 3, and adding or subtracting is going to give you 1. But this is impossible, because the only factors of 3 is 3 by 1. 3 and 1 is 4, or 3 minus 1 is 2, so you cannot factorize. You cannot break in factors. So in that case, I'm going to use the general formula. The general formula, A value is 1, B is 1, and C is going to be minus 3. So the values that I'm looking for, then in that case is going to be A and C, are going to be minus B plus minus the square root of B squared minus 4 times A times Z, and everything over twice A. A is going to be over here and here. V should be here and here, and Z is going to be here. Okay, here I'm going to have minus 1 plus minus the square root of 1 squared is 1 minus positive, and minus is going to be positive. 4 times 1 is 4 times 3 is going to be 12 over 2. X is equal to minus 1 plus minus the square root of 13 over 2. So in that case, I'm going to have x, well, I'm going to call x1, that is going to be minus 1 minus the square root of 13 over 2. That this is going to be approximately, in that case, I'm going to use my calculator, and then I'm going to try it. It's going to be minus 1 minus the square root of 13 and everything, I'm sorry, I'm going to do it again, I'm sorry, minus 1 minus the square root of 13 over 2. This is approximately minus 2.3027. As you can see, it is correspondent with this. Is between minus 2 and minus 3. It's minus 2.30. And x2 is going to be minus 1 plus the square root of 13 over 2. And this is going to be approximately a number that is between 1 and 2. So now let's try it. I'm going to use the same procedure over here. It's going to be minus 1 plus the square root of 13 over 2. As you can see here is 1.3027. And this is correspondent between 1 and 2. So here, with this one, we are going to have, we are going to have the intervals of the function. Remember that we are going to calculate first, second, and third areas. The first area is going, the interval is going to be from minus 2 to 0. Second one is going to be from 0 to this point, that in that case is this one. And the third one is going to be from this value from 2 to. Okay, so I'm going to call this A1 first area, A2 second area, and A3. Okay, remember that it is very important that you at the beginning of you need to draw the representative differential like that one, representative differential rectangle. Okay, and remember that each one, the base of each one is going to be dx. First one, I'm going to write over here, second one, and this is going to be the third one. And the height of each one is going to be depend of the function. Height is the function, height the function, height is going to be the function. So my first, the a1 is going to be the integral from -2 to, in that case is 0, of the function. What is the function? The function is x cubic plus x squared minus 3x dx. This is going to be the first area. And remember that this area result is going to be positive. Area number 2 is going to be the integral from 0, that is this point, to this one. You want to have the exactly number. My recommendation is do not use the decimals. Use this one. So I'm going to write -1 plus the square root of 13 over 2 of the function x cubic plus x squared minus 3x dx. Remember that this is base times height. This is the area of only this one. But with this one, we are going to calculate all the areas formed from 0 to this point. And remember that this one, the result of that one is going to be negative because it's under the the axis of x. Finally, we're going to calculate the area number 3, A3. And this is going to be from this point, that is going to be this one, -1 plus the square root of 13 over 2 to 2 of the function, that is x cubic plus x squared minus 3x and dx. So here I have the three statements of the integrals. Remember, this integral is going to be positive because it represents the area that is up of the above of the axis. This one is going to be negative, but it doesn't matter. It only means that represent the area that is not above, is under the curve, and this one is going to be positive also because again we are calculating the area that is above of the curve. So the only thing that you need to consider is that you need to take the absolute value of each one. So it means that you don't need to consider the sign of each one, and the only thing that you need to do is just to add all the, in positive of course, all the results of the total area at the end. It's going to be A1 minus A2 plus A3. Why the total area is going to be minus A2? Because remember that this one is going to be negative, and negative with negative is going to be positive. Alright? So this is the procedure to calculate it. In fact, if you have a calculator, you can do it by calculator. Some calculators has this. It's possible to do it with this because it has the function. As you can see, you can press this key that you have over here. Look at this. If you press this key, you are going to have the integral, in that case, the integral format. And then you need to introduce here the function. In that case, the function is going to be x cubic. How to do it? Well, you need to put it alpha, look for x. I'm going to show you here. Alpha x, and then put it, the number 3 has an exponent. Then press the space, and then plus alpha x, and then in that case it's going to be square, and finally is minus 3 alpha x. And then I have all the function over here. The only thing that I need to do it is to give the intervals. Let's start with the first one. The first one is this one. That is, I'm just gonna need to press over here and then I'm going to put it the first one, that is minus 2, press the other one to 0. Then this is going to be equal to, and this is the first area value. I'm going to write over here, this is total area. Total area, it's equal to 14/3. Okay, so then I'm going to write minus, because I'm sure that the next one is going to be negative. So the only thing that I need to do here is just to back with the function and put it the new intervals. The first interval is going to be 0, and that like here. The second one is going to be this one. Remember, do not use the decimals. Use all this quantity like that one, and in that kind of calculators it's very easy to do it. You only need to press a fraction, and then you are going to write minus 1 plus the square root of 13 over, oh, I'm sorry, I made an error over here, so but don't worry, we're gonna erase this one, and right now it's minus 1 plus the square root of 13 over, I need to clear this 0, sorry, over 2. Then I have the second one, it's going to be equal to, and as you can see, I'm just going to have minus 1.0886. In that case, I'm going to have a negative, as I told you, a negative value. I'm going to write over here minus 1.0886. I'm going to take 4 decimal as a representative quantity. And the last one is going to be, remember, those are the intervals of the last one. I'm going to back to the function, and over here I'm going to clear. When I put it the fraction, I'm going to write minus 1 plus square root of 13 over 2, and then this one I'm going to clear it, and I'm just going to write the superior limit, that is number 2, and this is going to be equal to, and then I'm going to have plus, I'm going to write over here plus 1.7553. So as you can see, I have the first, second, and third area. The only thing that I need to do right now is just to add it. I'm going to add 14/3 plus, because here we have minus and minus, plus 1.0886 plus 1.7553. Okay, so it means that the total area that I'm looking for, total area, it's going to be, there you are, 7.5105 square units. Remember that we're calculating areas, and then we finish this problem. So it's very easy to do it, but remember, if you have a calculator, you can use it, but you only need to use it just to confirm your results, because you need to do it by hand, each one. Okay, this is going to be only for calculate to verify the results. Okay.